Good morning, everyone. Okay, so I have a question here that is about Form 4, Chapter 2, Force and Motion. And this question is actually part of the Form 4 midterm seminar for 2025. Now, if you would like to watch the full seminar online, you can find the link in the description box down below. Okay, if you want the PDF of just this question, you can also get it in the description box down below. Okay, so let's have a look at this question here. Now, the diagram below shows a ball, mass 100 grams, dropped from a height of 10.8 meters from the floor. What is meant by free fall motion? Okay, so free fall, right, basically means that when the object falls down, there is only one thing that is on the object. Okay, what is that one thing? It's gravity. Yeah, only gravity is pulling the object down. Now, is this possible in our normal daily lives? Actually, no. Because in our normal daily life, right, we always have more than one force on an object. Okay, so for example, if something falls down, even though yes, gravity is pulling it down, but there is usually air resistance. Okay, for free fall, we assume that there is no air resistance. Yeah. So it doesn't really happen in our usual daily life lah, okay? But normally when you see the question, it says free fall, normally that's what we will assume already. There's no air friction, there's no air resistance, okay? So you could say that the object is falling under the effect of gravity only. Okay, so nothing else. The object is falling under the effect of gravity only. Now, the word only is very important. If you say object is falling under the effect of gravity, I mean, this one can apply to whether with air resistance or without air resistance. Okay, so object always fall under the effect of gravity. But for free fall, it must be gravity only. Okay. Next, calculate the magnitude of the velocity of the ball as it reaches the ground. Now, if you want to know how fast is the ball as it reaches the ground, okay, you should be able to guess that this is actually a SUVAT question. Now, for those of you that don't know what is a SUVAT question, basically, you write down SUVAT, okay? That's how you spell SUVAT, right? Now, after you fill up all the information you have, you go to the formula sheet and you look for these four formulas. Okay, these would be your SUVAT equations. Okay, so you're gonna choose whichever equation is the most suitable based on what information you have and what are you trying to find. Okay, so let's just list down what information we have first. Now, first of all, the height. This S is the displacement. S stands for how far are you traveling? So in this case, that would be the height lah, which is 10.8 meters. The displacement. Okay, U and V are both velocities, but U means initial velocity. V means final velocity. Okay, now sometimes students, they get confused. They don't know which one is initial, which one is final. Very easy. You know your ABC, right? Okay, your A, B, C, D, E, F, G. Which one comes first? S, T, U, V, W, right? So U comes first, V comes after, okay? So the initial velocity. Now, when something is dropped, initially, that thing is being held, okay? So initially, that thing is not moving. So initial velocity is 0. But if the thing is being thrown, as in I throw it down, that means at the start, I have already given it a speed already. So that one would have initial velocity. It won't be 0. Okay? So in this case, it is dropped. So we know the initial velocity is 0 meters per second. Okay, what about the final velocity? That's what we're trying to find. Yeah? When the ball reaches the end, right before it touches the ground, right before it actually stops, what is the speed? What is the velocity? So that's what we're trying to find. I'm going to put a question mark here. Now, for the acceleration, again, because this thing, right, is falling due to gravity, then the acceleration must be the acceleration due to gravity. and acceleration due to gravity is 9.81. Okay, so I don't know if you've ever noticed, but when we talk about this G, as in like weight equals to mg, this small letter g, right, will always be 9.81 meter per second square. That's the units for acceleration. Okay, so why is that? Because imagine, right, this ball, before you let go, he's not moving, the velocity is 0. After you let go, he starts to move. So when you go from no velocity to some velocity, you must have been accelerating because your velocity changed already. Okay, so that's why gravity causes an acceleration. Yeah, 9.81. Now, what about the time? I don't know. There's no information about the time. In fact, the next question is asking me to calculate the time. So I'm just going to put a dash here. It means that I don't have this information. Okay. So now what I need to look for is which formula has S, U, A, and what are you trying to find? You are trying to find V. Okay. Yeah. Now, for those that already know how to do this, I'm sorry I'm going a bit slow because I'm trying to cater for the people that still don't know how to do Suvat yet. Okay. So I know normally for my students, also they already know what's Suvat already. They already know what to do already. Okay. So SUA because you have these things, and V because you want to find that. So look through the 4 formulas. There is actually only one formula that has this combination only of S, U, V, and A. If you notice, this one got no S, right? And this one got T, cannot find. This one also got T, and it has no A, right? What about, let's say, this one? This one also got T, so cannot find also, okay? And there's no A. So we only have this one left. V square equals to U square plus 2AS, okay? Plus 2AS, right? Now I'm just going to substitute all the numbers inside. So V square, I don't know. U square is 0 square plus 2 times A is 9.81 times S is 10.8. All right. So you're going to get V square is equals to, let me just very quickly calculate. 2 times 9.81 times 10.8. So you get something like 211.896, okay? Then now you got to square root the answer. So let me just square root this. Oops. Hang on. Okay, square root the answer, and you should get 14.5566 or 14.56 meters per second because it is a velocity, right? So 14.56 meters per second. Okay, then the next question, how long does the ball take to reach the floor? You can basically write back the same thing, okay? But this time, instead of trying to find V, you are trying to find T, okay? So instead of using SUVA, you now use SUAN T, the thing that you're trying to find. Now, could you use V since you already have the number here? Let's say I want to use UVAT. Could I do that? Of course, definitely. Yeah, technically it's not wrong. But how sure are you that your answer for V is correct? Yeah, during your exam, right, you cannot check your answers. So you don't know whether the number that you have gotten is correct or not. So might as well use the numbers that they have given so you know that you are absolutely correct. Okay? So if I look for the formula that has SUAT, you're going to end up with this one. SUA and T. Okay? So S equals to UT plus half AT square. Again, substitute all the numbers. 10.8 equals to 0t plus half 9.81 t squared. Okay, now 0t is of course just 0. I'm just going to ignore that. And I'm going to bring this over to divide since I want t squared by himself. So t squared is equals to, so 10.8 divided by 0.5 times 9.81. Okay, so 2.201835. Okay, now t, I just have to square root it, and I will get 1.484. Okay, 1.48 seconds, of course. Yeah, everything we are using SI units, so our answers will also be in SI units. Okay, seconds. All right, next. If the mass of the ball doubled, what would happen to the time taken? Okay, so if you've ever searched for a video, if you go on YouTube and you search for a video, bowling ball and feather falling in a vacuum, okay, you will see that the mass does not affect how long it takes for you to fall down. Okay, when you drop a bowling ball and a feather right now, in real life, you will get the feather falling slowly. It's not because it's lighter, it's because there's more air resistance. Okay, so if you take out the air, if you do it in a vacuum, if you do it in space, they actually fall down together. Okay, so right now we are saying free fall, no air resistance, then no matter how heavy the ball, whether it's a bowling ball or a football or a ping pong ball, it's gonna fall down same timing. Okay, unchanged. Now, another way to prove to you that it's going to be unchanged is when you look at the formula, when you look at this suvat, did you change anything in the suvat? When the mass of the ball doubled, did you change anything? Did you change your falling distance? No. Did you change your starting velocity? No. Did you change the acceleration? No. Yeah, this is due to gravity. So everything is the same. Of course, you're going to get back the same answer, the same time. Okay? Next one, sketch a velocity time graph and a displacement time graph of the motion of the ball. Okay, we're going to start with velocity time first. So V in meters per second, and then time in seconds. And then we're going to go ahead and draw a displacement time graph, D, which is in meters. Displacement should be S, because the S in suvat is displacement, yeah? Okay, time in seconds. Now, for the velocity, right, I want you to think of it like this. When it falls down, what is happening to it? I told you just now, right? It accelerates because of gravity, yeah? Gravity causes an acceleration. Now, this acceleration is a fixed number, which means your velocity, your speed, will increase steadily. Your velocity will always increase at 9.81. So 9.81, and then you plus 9.81 again, and then you plus 9.81 again, and then you plus 9.81 again. So your velocity actually increases steadily, which means your graph will be like this. It's a straight line. Okay? So you can even get the numbers, which is 1.48 seconds for the final moment. And your final velocity, you would actually get, 14.56. Okay? But the displacement graph is not so straightforward, because if your velocity keeps increasing, that means when you travel, right, you are traveling further and further and further. You get it? Every step you take is going to be a bigger and bigger step, because your velocity is starting to get faster and faster. So this means that your displacement graph will actually curve upwards like this. Okay? Yeah. If you remember the relationship between displacement and velocity, you will know that the gradient of this guy is actually the velocity. So I'm telling you now, the gradient keeps increasing. What does that mean? The gradient keeps increasing. That means your slope is getting steeper and steeper. Okay? So that's why I curve up like this. Yeah? So the final displacement, maximum displacement is 10.8, because that's how far you can fall. And again, the final time is 1.48. Okay? Now, the last question, calculate the impulsive force acting on the ball when it lands on the ground. So for impulsive force, right, if you look back at the formula, you don't really get impulsive force in this formula. But you should know that all forces can actually be written as F equals to ma. So even impulsive force can be written as F equals to ma. Sorry about that. Okay, so F equals to ma. Now, what is the A? If you don't know the formula for A, don't worry. Go back to your Suvat. Okay? Look at this formula here. You can convert this formula into A equals to V minus U over T. Okay? Now, if you don't know, pause the video, try that. Try to convert this formula into this. Yeah? See whether it works or not. Okay? So I'm going to substitute this. So I'm going to get V minus U over T. Alright? Then from here, I have all the information I need already. The mass of the ball is 100 grams. Always change to kilograms because that's your SI unit. 0.1 kilograms. And then the final velocity is 14.56. The initial velocity is 0 divided by the time taken to fall down, 1.48. Oh, sorry. This time taken, my bad. This is not the time taken to fall down. This is the time taken for the impact. Yeah, the impact time is 0.8 because impulsive force only happens during impact. Okay? Yeah, my bad. So 0.8 seconds is the impact time. All right? So now you can just calculate this. 0.1. Hang on. 0.1 times 14.56 divided by 0.8, and you're going to get 1.82 newtons. It's a force, so your units will be newtons. Okay? Now, of course, some people you might have just memorized the formula for impulsive force, which is F equals to mv minus mu over t. Sure, you can go ahead and use this formula. It's the same thing. It's the exact same formula. Okay? Right? So once again, if you want to get the full seminar, you can head on to the link in the description box below. Okay. If you learned something, remember to like and subscribe, and you can let me know in the comments what chapter exercise do you want me to do next. Okay. I'll see you guys next time. Bye bye.